Welcome to Energy Calculations. Here are some important information you guys might need to know. 1A. Assume the lights in your kitchen uses 300 watts. How much energy and how much does it cost to leave the lights on 24 hours a day for a week if electricity is 8 cents per kilowatt hour? So what we need here is the energy equation. Energy equals power times time. So I have power, that's in watts, but I need it to be in kilowatts. So that's what I'm going to do. I'm going to change my watts into kilowatts. So that cancels out and I divide and I get 0.3 kilowatts. Next, I need my energy. So it's power times time. So that power is in kilowatts and I need it in kilowatts hour. So that's what I'm going to do. All I'm going to do is I'm going to be multiplying it by 24 hours in one day, and we're going to be calculating it for a week. So I need to change days into weeks. So there are 7 days in 1 week. Days cancel out, and I multiply. I get 50.4 kilowatts hour per week. So now I have the energy that is used for that week. I need to get the cost. So to get the cost, I simply take the energy produced in 1 week and multiply it by the cost, and I get $4.03 per week. 1B. How much energy and how much money do you use to run a window air conditioner rated at 1500 watts continuously for the month of July? Assume 8 cents per kilowatt hours. So we have the same issue here, y'all. We need kilowatts hour, but we only have watts. So I need to convert that 1500 watts into kilowatt. So I divide and I get 1.5 kilowatts. Energy is power times time. So the time we want is hours. So I take my kilowatt and I'm going to do it per hour. And there's 24 hours in a day, and we want for the month of July, and that's 31 days per month. I cancel out days and I multiply my numbers to get 1,116 kilowatt hour per month. Now I want to know how much money it costs. So I take the kilowatt hour produced per month and multiply it by the cost per kilowatt hour, and I get $89.28 per month. 1C. If you assume that coal was used to produce the electricity for your air conditioner, how much coal was burned to produce the electricity used? So you have to take the information from 1B, the 1,116 kilowatt hours per month, and use the conversion factor that's provided on your worksheet. The conversion factor is 1 ton of coal equals 2,500 kilowatt hour. So I set it up so that kilowatt hours cancel out. And so I divide the two numbers to get 0.45 tons of coal per month. 2A. If your car gets 20 miles per gallon and you drive an average of 15,000 miles each year, how many gallons of gas do you use each year? So I need to write out my conversion factors first. I have that we drive 15,000 miles for 1 year. And then we have 20 miles to 1 gallon. Let's set up our problem. So we start off with year. And then to cancel year out, I put year on bottom, and my conversion factor is 15,000 miles on top. Then I don't want miles, I want gallons. So I put 20 miles on bottom, 1 gallon on top, and I divide 15,000 miles by 20. And I get 750 gallons. At $3 a gallon, how much will you spend on gasoline for the year? So our conversion factor would be $3 equals 1 gallon. Then I take the value from the previous problem, 750 gallons, and then gallons on bottom, dollars on top. I multiply and I get 2,250 for the year. 2C, if the combustion of each gallon of gasoline produces 22 pounds of CO2, how much CO2 does your car produce each year? So I need to write down my conversion factor, 22 pounds of CO2, and then it is 1 gallon. So I use the value from the previous problem, 750 gallons, and then I put gallons on bottom, 22 pounds of CO2 on top, I multiply it, and I get 16,500 pounds of CO2. 3A. Given that 1 kilocal of heat is required to increase the temperature of 1 kilogram of water by 1 degree Celsius, how many kilocalories would be required to heat 100 kilograms of water by 20 degrees Celsius? So I'm going to use ratios for this, y'all. I'm going to set it equal to each other, right? So we have 1 kilocal is over 1 kilogram times 1 degree Celsius. So that's this information here. Then I'm going to set it equal to how many kilocalories, that's my x, over the 100 kilograms of water by 20 degrees Celsius for a bath, and that goes on the bottom. So now I'm going to cross multiply. So when I do, I have my units here, and it is equal to 2,000 kilocal kilogram degrees Celsius. So to solve for x, I'm just going to divide by the unit, it cancels out, and I get 2,000 kilocal as my final answer. 3B, how many joules is this? So to do that, I need to use a conversion factor of 1 calorie is equal to 4.184 joules. So 2,000 kilocal, I convert it to calories, and then I set calories on bottom, joules on top. I multiply, and I get 8.37 times 10 to the 6 joules. 4A. A typical home in the northern US might require 120 MBTU of heat for the average winter. If this heat were supplied by a natural gas furnace operating at 60% efficiency, how many BTU is needed? So I need this equation, y'all. Input times efficiency equals output. So this problem says that it requires 120 MBTU of heat for the average winter. That is my output, y'all. The 60% is the efficiency, and I'm solving for input. So in order to solve for input, I'm going to be dividing by 0.6 on both sides, and I get the input to be 200 MBTU. So to convert from mega to just BTU, I need dimensional analysis. So we know 1 MBTU is equal to 1 times 10 to the 6 BTU. MBTU cancels out, I multiply, and I get 2 times 10 to the 8 BTU. How many cubic feet of gas would need to be purchased? So I need the conversion factor of 1 cubic feet equals 1,030 BTU. So I start off with the BTU that is the input, and then I'm going to put BTU on bottom, cubic feet on top. Then I'm going to divide, and I get 194,174 cubic feet as my answer. 4C. At a cost of 90 cents per CCF, what would it cost to heat this house for 1 season? So I need the conversion factor of 1 CCF is equal to 100 CF. So I take the value that I had before, and I'm going to convert it into CCF. Then I'm going to have CCF on the bottom and 90 cents on top. And I'm going to multiply and divide, and I get the answer of $1,747.54. 6A. The half-life for potassium-39 is 45 minutes. How many minutes will be needed for 1/8 to remain of the original amount? So for half-life problems, y'all, I'm going to constantly divide it by 2 in order to determine how many half-lives occurred to get to 1/8. So I start off with 1. Okay. And then move on to 2 half-lives. That's 1/4. 3 half-lives is 1/8. So I know that I need to multiply 3 by 45 minutes, and I get 135 minutes. 7A. The half-life of oxygen-18 is 14.5 seconds. How many milligrams remain after 29 seconds have passed if the original mass was 6.2 milligrams? So we need to determine how many half-lives have occurred. Okay? So 29, I'm going to take that divided by 14.5 seconds, and I get 2 half-lives. So I'm going to divide the mass twice. So 6.2 milligrams divided by 2 gets me 3.1 milligrams. I'm going to divide that by 2, and I get 1.55 milligrams as my final answer. Okay, y'all, that's it for today. Have a good one.